Hello and what's up to you all matriculants, lovely matriculants. It is an awesome Thursday and it is time for maths literacy. Guys, you know we're going to learn more and learn extra together. I'm not alone as Abram, I'm with John. John, how's it?
I'm really good, thanks, and welcome to you guys out there. Today we're doing some mathematical literacy because Peter, who's normally here wearing a purple shirt, he's off to sunny Florida to Disneyland. But he'll be back in a little while.
I envy this guy. You know, I just so wish to be like him. But otherwise, I'm getting used to your face, John, on Thursdays, so it's good. What are we doing?
Great. I hope I'm managing okay and getting all those questions right. So, guys, today we're dealing with probability. And I hope after this lesson, you'll understand a little bit more about what probability is. And you'll also understand how lucky draws and entries to competitions work, because that's what we're dealing with today.
Yeah, you're going to be teaching us a bit of gambling with cards
No,
and
not
dice.
gambling. No, not gambling. No.
We
But
need to get to know our chances.
surveys, understanding, weather forecasts, all of that stuff we'll be talking about, because you know what, probability is everywhere. And I know that the guys back in the studio there, James and Abram, they love probability. So we'll try and see if we can include them as well.
Well, guys, I hope you're going to like it too. Well, to get connected with us, go over facebook.com/learnextra. That is our Facebook link. I like the page. You should be knowing it by now, because at the moment, we've hit 88,000 likes, guys. So keep sharing with your friends. I hope Join has got something special, or maybe we might get something special for you guys, because we always have giveaways, but there are lots of giveaways that I need to give you during this break. So do stay during this show. Do stay tuned. Follow us on Twitter as well at LearnExtra, and remember to download your notes or to view them. The links are posted on Facebook, but you can also get them on learn.mindset.co.za anytime. John?
Thank you so much. And guys, remember as well, if you happen to miss the show, or your friend happens to miss the show, the videos are posted in a couple of days' time, so you can watch them there on the page at learn.mindset.co.za. Just click on the Learn Extra Live thing, go to the schedule, and you'll find it out there. Okay, so probability. As I said, we're going to start off really simply. We're going to revise how to find the probability of an event or events taking place. And then we're going to calculate and apply probability to different situations. And because Peter's not here, I thought, well, let's talk about his holiday. And although we know that he's off to Disneyland and he's also visiting some family, here's a scenario that I want to talk about. At Disneyland, he has the choice of going on different rides. So it's a bit like, you know, Ushaka World, or something down at the bottom, Gold Reef City, and there are all sorts of Ratanga Junction in the Cape, these fun rides. But Disneyland is bigger, and there's so many more. So he's got a choice of going on different rides. How the time you need to spend waiting for a ride is approximately 75 minutes. And sometimes, guys, those queues are even longer, but the average is 75 minutes. So you spend 75 minutes waiting in a queue, and then you might spend about 5 minutes on the ride, and then you've got to start the process all over again. So the park opens at 9 o'clock in the morning and it closes at 9 p.m. And the challenge question for you to work out, there's just one that I thought was quite fun, is how many different rides can Peter possibly go on in one day? So you think about that, do some calculations. And then what is the probability that Peter will go on? No rides in a day, 15 rides in a day, and 6 rides in a day. Give me some answers. I want you to comment on the Facebook page. The challenge question is there. Just go down a little bit. It's not right at the top, but it's just down a little bit. Comment. Let's see what you think about particularly these 3 answers here. Number A is just to get you thinking, but number B and the 1, 2, 3 parts, those are the real challenges. So let's get some discussion going. Cool.
I can't wait.
Okay, so now the next thing is, let's just do a little bit of a summary, and we're going to talk about what is probability. And we have different ideas about what probability is. And I know that there are lots of people that are confused about probability. The one way to undo all the confusion about probability is to recognize that it is like a number line. And so at the one end of the number line, we've got something that is impossible. So in words, at that end, it's impossible. And at this end, we're going to say it's certain. So somewhere in between the impossible and the certain is where life happens. And we sometimes not sure of what tomorrow is going to bring. We can think we have a good idea, but between impossible and certain, because we know that there are laws that govern the way our lives live, we can have certain expectations. And so we know certain things are going to happen in the future. We know, for example, that tomorrow morning we might not see it, but it's going to change from night into day. And that's going to happen somewhere between 5:30 in the morning and 6:30 in the morning. It's getting lighter in the morning, guys. Great time to study. Get into some study before you go to school. So between that time and that, we know the sun's going to rise. It's certain. It would have to take a huge disaster for that not to happen. And we wouldn't know about it in any case because we wouldn't be here to tell the answer. But if I had to say to you, the sun will rise in the west, well, that's impossible. We know that the sun always rises in the east. It's not possible for it to change suddenly and reverse its motion. Physics doesn't allow us to do that. If we suddenly said, if we jump up and we don't fall down, that's going to be impossible as well, because we have mass and the earth has mass, and we're not going to get into a physics lesson. So there's some things that are impossible and some things that are certain. There are other things that are less sure, and there's a 50-50 chance of it happening. So for example, the chance of Abram getting to work on time tomorrow, waking up in time to get to an appointment. We have a meeting at 11 o'clock. Whether he's going to make it, well, you never know. You know, he could have a flat tire. He could have a petrol run out. He might hit heavy traffic. Most of the time, Abram's very reliable. He gets to his meetings on time and sometimes even ahead of time. So if I were to look at it and I say between impossible and certain, I'm going to say Abram getting to his meeting, AB on his meeting. How would I represent that? Yeah, he's got it's more certain than impossible. So what I want you to understand is it's difficult to describe that in words. Because Abram's a dependable sort of guy, we are saying there's more chance of him being there on time. There's a small chance of him being late, and there's a chance that maybe something terrible happens overnight and he can't make it. So we can't be absolutely certain. Okay? I hope you understand that. So instead of just using words that are very airy-fairy, let's put some numbers to it. Because in mathematical literacy, it's not just about literacy, which is words, but it's about numbers, the maths part. So if something's impossible, we're going to say the chance, words of probability are related to chance, the chance of happening are non-existent. It's impossible. We're going to say that's a probability of 0. Of something happening, we're going to say that's 100% or 1. The probability is 0% or 1. Okay? So here's another idea here. If we say that something's got an equal chance of happening, so for example, like flipping a coin. Well, how many sides does a coin have, Abram?
2.
2. So if I flip a coin, there's a chance that it could get heads, and there's a chance it could get tails. So there are 2 possible outcomes, but only one can happen. Do you agree? You can't get heads and tails at the same time. So out of the 2, only one. So 1 out of 2 things could possibly happen. 1 out of 2 is a half.
Yes.
And a half we could write over here as 0.5. So you could write it as a common fraction as well. You could say it's 1 out of 2. And there's some people that will even say 1 is to 2. So 1 out of 2 as a ratio. We're not going to get into the gambling side where people give you odds for gambling. And they can say there are short odds or there are long odds. And I don't even understand all of that. For every R1 you give me, I'll pay you R6 if your particular event happens. So 1 to 2 is 50%. The chances of Abram being on time, I think, are probably closer to about 80%, because he's usually quite dependable. Another way of writing 80% would be to say 0,8. And another way would be to say this. In 10 days that I've set up appointments with Abram, 8 out of those 10 days, Abram's there. So we would say 8 out of 10 as a chance. 8 out of 10. Okay? Fraction. So I hope you can see that there are different ways of writing it. Percentage, a decimal fraction, a common fraction, or even as a ratio. So let's just get a little bit more specific about how we calculate ratio now, or how we calculate probability. And to do that, what I want you to understand is that we have to first of all count. We have to count all possible events. And then what we've got to calculate is we've got to count the desired event, the favorable. They often call it the favorable, or the one we want. Favorable event. And we then take a fraction and we say, let's take the one that we want, what we want, divided by all. And I've just summarized, and that will give you the probability. Very, very simple. So, Abram, I need you to come and join me here, please.
Okay, John.
Okay, so I want to give you a secret. I want to explain to you. In a box, when we do the draws for like the giveaway for the Casio calculator or for the winter school programs or for Vodacom airtime, all of that sort of stuff, what we do is we put the names of everyone that's entered into a box, right? Now, I didn't want to put hundreds of names into a box because there are too many and it will take us too long to count how many there are. So I've just taken some names. I want you to hold them there and count all of them for me.
Okay, there are 5.
There are 5 names. Okay. So now if we look on them, one of those pieces of paper, this one has got a little cross on it. Can you see it?
Yeah.
Blue cross. Hope you can see it from that distance. Maybe just come a little bit closer to you. I hope you can see there's a blue cross. I'm putting 4 that don't have any writing on them other than the names from a previous draw. Okay, they're all blank. All of these, Abram, verify, they've got no writing on them. Hey?
Yep.
They've got no writing on them. They're all, only this one. So we've got 5 names in the box. Okay.
Yes.
And we've got one that's got a blue thing. Just hold that for a minute. So I need you to understand the total number of tags that I can draw out of the box is 5. That's the total. And only one of them has got a blue cross on it. So the total number is 5. And the one that I want is the one with the blue cross. And that gives me 1 out of 5. Total number of things that I could draw out, 5. Only one is the one that I want, so it's 1 out of 5. Could write that as 0,2, which I could also write as 20%. So I could also write it as 1 in 5. Okay. Now, what I want to show you, that's the theoretical prediction. Okay? Understand that. That's the theoretical prediction. But it doesn't necessarily always happen like that. So what we're going to do is we're going to say to Abram, close your eyes and put your hand in and take out a piece of paper. Take out a piece of paper. And take a look. He wasn't watching. What has it got? It's got the cross on it. Wow. So out of one chance, out of one draw, the first time Abram drew the right one. So can you see? It's not the same as the prediction. It's the reality. Let's try it again. Let's see if you can do. Now, he's not magic or clairvoyant or we've got magnetic fingers, but let's see if he can find.
You'll never know, John.
Okay. And this time, he hasn't drawn it. Okay. He got a blank one. I'm putting the blank one back in the box. Let's do another one. Okay. So we've done 2 draws. And another blank one. So out of the 3 draws that we've got 1 right one, we've got 2 wrong ones. Let's do another draw. And can you see it's starting to mean that he's not getting the right one again? We've done 4 draws and we've only got the one that was right once. Okay, I've thrown one away. Let's do that. Let's put it back. Go for it. And there we've done 5. So in our little experiment, out of 5 draws, we only got the one with the blue cross once. So the theory seems to match our experience, even though Abram got it right on the first time. Now, we'd have to do another 5 draws to see if we got it again, to show that in reality it's correct. But it seems to work. Okay, we'll come back to the box just now, but I think it's time for a break.
It is. Well, during this break, Mindsetters, you do have the challenge question posted on the page. Get on it right now and do download your notes or view them. We'll see you after this break. Welcome back, Mindsetters. Remember, on the giveaways that we do have this awesome Casio calculator. Just by answering the test yourself questions, you stand a chance of winning this awesome Casio calculator. And I must say that mathematical literacy questions, they're just simple for you guys. And John is not being hard on you guys. Even on the challenge question, it's so simple. If I were to get that trip to Disneyland, I was going to give you that, guys, the answers. John, if only.
If only, hey?
Yeah.
But you know what? Peter worked really hard and he saved lots of money and he kept it invested for a long time because he did his finance calculations as well. So let's get in on the next part of it. We're going to go to our questions. Just to follow up from what Abram said. Guys, I want to tell you a little secret. To win that Casio calculator is really straightforward. I can't give you one for last week because you know what, Abram? For maths literacy, there was only one person that entered and they didn't even get half the marks right, else I would have given the prize. Okay? So guys, I want to see at least 40 of you registered. Do you think that's possible?
These guys are brilliant, John.
Hey,
what are you
come
telling
on.
me, John?
Hey.
I'm disappointed now.
So they need to register. If you're struggling to get onto Curio and follow the link, message Abram and we'll help you. Okay? We want to give that calculator away, but we couldn't tonight because nobody deserved it. So I tell you what, we've got 2 calculators tonight.
Okay.
Okay,
All right.
2 calculators.
All right.
So guys, think about this. If 10 of you enter, what's the probability of you getting a calculator? Well, in this case, it's a little bit more definite. You just got to make sure that you get the right answers. Okay, because it's not just a lucky draw. Okay, it's not just taking the names out of the hat. I want to see the marks. I want to see the right answers. Okay, so let's go to this one. Now, I don't know how many of you are aware. There's some people in the background there that are really interested in their soccer. And I don't know, do you have a favorite team?
Soccer.
Soccer.
I've got 2.
Hey?
You've got 2.
You've got 2.
Yeah.
Local?
Kaizer Chiefs.
Kaizer Chiefs.
Yes.
Is that 2 teams?
Kaizer Chiefs and Orlando Pirates.
You
But I go for Chiefs.
You go for Chiefs.
Yeah, it's a family thing. Like with like other people support this, so sometimes I'm caught up in between. But Kaizer Chiefs.
That's give a simple answer. I was wondering whether there were 2 teams you support, Kaizer and Chiefs, but I don't. Yeah,
Kaizer Chiefs. Kaizer Chiefs.
One team. You say it's Chiefs. Now I know that somebody in the background, Abram, the other Abram,
Yeah.
he likes Sundowns. So even though they've done badly, I mean they only won last night the first time in 3 games. So yeah, he thinks they're going to win the league. I don't know the probability of that. How do we know? Certain, uncertain? I tell you what's the probability? Here's something we can answer. What do you think the probability of scoring 100 goals in a soccer match?
It's impossible.
It's impossible.
It's impossible.
Because how long have you got?
90 minutes.
90 minutes.
Yeah.
To score a goal every minute? Not going to happen, is it?
You still can't get 100.
You can't
of
get
them.
100
Yeah.
goals. I don't think that's possible. Even if you have to take the goalkeeper
Unless
out.
you're playing
and
alone.
if you're paying for, playing alone. But if you're Sundowns, you're not going to score those goals even without a goalkeeper. So
Why are you on the tip of dissing Sundowns?
it's just teasing
okay,
Abram.
okay.
Okay.
I wonder what's your team.
No, I won't reveal that right now. Okay, so I believe there's some problem with the sound every time I say that particular name of that team from Pretoria. Let's have a look at another sport. And this particular game, or this particular question, we have to say what the probability is: impossible, below average, 50-50 chance, above average, certain, and if it's impossible to tell, or if it's impossible to tell from the given information. So maybe there's information, we don't have enough information, so we can't make a calculation. So in this case, it says, first one, like the soccer team, a cricket team will score 700 runs in a T20 international. Now, guys, T20, how many overs do we have in a T20?
I don't know.
No. T20. What's the 20 stand? 20 overs. Okay, so guys, let's look at it. 20, and an over has 6 balls. So 20 times 6 is 120. So you've got 120 balls. And you want to try and get 700 runs. Let's have a look at how many runs you've got to get per ball. So if you've got 120, you want 700 divided by 120. Let's see what that fraction is. 5.8 runs per ball. Do you think that's likely?
6 balls?
What's the maximum you can get from one ball?
6 runs.
6 runs. That's right. You have to hit the ball way up. Can you do that for every ball?
No.
No. There's been some cases where they've had 6 sixes in an over. But 12 sixes in a row, it hasn't happened. Do you see that this 700 runs? Nah, impossible. Probability equals 0. Okay, it's humanly not going to happen. And if you think about it, the maximum number of runs they've scored in 50 overs is just about 450. Okay, that was 50 overs. Now we're talking about 20 overs. 700, not going to happen, guys. It's impossible. Now let's move on from sport. Let's move on to another topic, another subject. Heritage Day. Do you like Heritage Day?
Yes, I do, John. Yeah.
It's really nice to hear about other people's heritage and to, exchange ideas on Heritage Day and recognize we're a rainbow nation, we've got things in common, and not just Braaivleis. It's not Braai Day. I know it's called Heritage Day, and we usually have a Braai, but it's more about that. So what's the probability that Heritage Day, and I want Abram to answer in my ear here, what's the probability that Heritage Day in South Africa is on the 2nd of September this year? So can we hear the answer? We're just waiting for James in the background. James, can you get Abram to tell us what's the probability? Is it 0 or is it 100? Abram is telling me that it's 100. No, Abram, it's not 100%. Abram, you need to understand. 100% is certain. 2nd of September is the wrong date for Heritage Day. Heritage Day is the 24th of September. Am I right?
Yes, you
Abby?
are. Yes.
24th of September. So the chances of Heritage Day being on the 2nd of September are?
0.
0. Thanks, Abram. Yeah, you've got the right answer eventually.
Abram.
Okay, so we've got 2 Abrams in the studio tonight, but we've got that probability sorted out. Okay, next one. Here's a more difficult one. I want you to think about it very carefully. Heritage Day in South Africa falls on a Monday. Ooh. How many days in the week are there?
7.
7.
Yeah.
So what's the probability that Heritage Day is going to be on a Monday. Notice it doesn't say a year. Okay? Doesn't say a year. If it said in 2014, then we'd be able to check and we would say, Heritage Day is on a Wednesday this year. So if it was in 2014, well, there's no chance of it being on a Monday. We know that. Okay? But what's the probability that it will fall on a Monday? Well, it has to fall on one of the days of the week. And for one of those, there are 7 days in the week, total number. Remember, we calculate probability by looking at the total, and they're deciding what's the favorable is. So it's 1 out of 7. And if I work that as a fraction, then I'm going to see that 1 divided by 7 is equal to 0,1428 or 29, 0,1429, and I could write that as 14,29%. 1 out of 7. Make sense? Abram, you follow?
Yeah.
Okay, cool. So here's the next one. What's the probability that it will rain on Heritage Day this year? What's the chances? Okay, remember we've got the number line from 0 to 1. Now, understand when Heritage Day is. It also depends on where you're staying in the country. So if we had to say, I was living in the Northern Cape, it doesn't really matter. The chances of there being rain would be somewhere down there. If I was in the Northern Cape, that's the Northern Cape. But if I was in the Western Cape, it might be a little bit low as well because it's starting to get to spring and there's less rain in the Western Cape in spring. But when we take a look at Gauteng and we're in the northern parts of the country, then the chances are above 50% because if that was 50, then what we're recognizing is we're starting to get to, or 0,5, 50%, same thing, in terms of probability. We're starting to get to those winter or those spring thunder showers. So the chances are the end of September, there's a bigger than 50% chance. And I don't even need to go to the Weather Bureau to go and look at that. If I want to be specific, then I need to get the long range forecast. And at the moment, 24th of September is too far away, and I won't really even know what's going to happen. When we get closer to the time, you'll see on the news, the weather predictions will come and say, there's a 40% chance of rain tomorrow. In fact, that was one of the things they said tonight on the weather during the day. Tomorrow, 40% chance of rain in the Gauteng region. Well, what do they mean? They're saying if we look at the pressures and we look at where the cold fronts are and the conditions are, in 4 days out of 10 days, there will be some rain. Okay? 40% chance of rain means with those conditions of pressure and wind and all that sort of thing, looking back in our history, for out of 10 days, if we had all of those conditions, we mapped them, 4 out of the 10, there would be some rain. Now, some rain doesn't mean a liter of rain. It doesn't mean 2 millimeters of rain. It could be anything. Even if there are a few drops, then it's rained. Okay? But there will be some rain 4 out of 10 days. Means 6 out of 10 days, there's a chance that there won't be rain. So tomorrow, if it's 40% chance of rain, I wouldn't pack an umbrella. I wouldn't pack my raincoat, because there might just be a little bit of rain. There might be no rain, because 6 out of 10 chances are that there will be no rain. Okay, makes sense?
Yes.
Right, now we're getting on to one that's a little bit more difficult. It's a little bit more involved. And I'd really like to get through this, because this is the type of question that you could get asked either in paper 1 or paper 2. So please try and follow with me, because it helps us understand a little bit more about probability. So we've got Mr. and Mrs. Jones, and they decide to have 3 children. Okay? We're asked what is the probability that their first child will be a girl. Well, guys, there's not much problem here, because we recognize what are the choices. They could have a boy or a girl. So the possibilities are either a boy or a girl. So there are two things. And so the number of possible outcomes are two. So what do we want? Well, we want the girl, and we can only have one out of two ways of getting the girl. So the probability of the girl is 1 out of 2, which we could write as 0.5, which we could write as 50%. I'm not going to continue writing it all those ways, but we're just going to do it in one way from now on. Okay, what's the probability that they will have 3 boys? So now, this is one that you need to be very, very careful with. Okay? So, if we do this, let's see what all the chances are, all the ways of getting. In the first time they have a child, it could be a boy or it could be a girl. The second time they have a child, it could be, I'm using a different color, a boy or it could be a girl. So the next time they have a child, it could be a boy or it could be a girl. So in the first time, there are 2 possible outcomes, and we're going to say, out of the 2, we want 1. And out of the 2 possibilities, we're going to have 1. And out of the 2, we're going to have 1. Only 1 out of the 2 is favorable. The boy, the boy, the boy. And we want to have a boy first, and a boy second, and a boy third. Now, if you heard what I've said, and it's in the notes as well, every time we say that we want more than one event that's not happening at the same time, and we're including those, and we're saying we want this and that, then in probability working, we multiply the individual probabilities together. So in this case, we're going to say the probability is equal to a half times a half times a half, which is equal to 1/8. But now, let's check if that's right. Let's check if that's right. Because what I want to do is I just want to write down all the possibilities. So, have a look here. First child, second child, third child. So the first child, I could have a boy, or I could have a girl. In the second child, I could have a boy, or I could have a girl. In the third child, I could have a boy, or I could have a girl. So what are the possible scenarios that we could have? We could end up with one scenario where we have 3 boys. That's 1. Count with me. That's another scenario. I could have 3 girls. That's 2. What's another scenario? The first one could be a boy, the second one could be a girl, and the next one could be a boy. That's how many? 3. Now, the next one, I'm going to say, the first, let's use another color. First one's a boy, the second one's a boy, the third one's a girl. That's 4. Okay? Now, if I go on, if I say to myself, right, let's choose another one. Let's say the first one is a girl, the next one is a boy, and the next one's a boy. How many is that? 5.
5.
Okay, let's see if we can find another couple that we've missed out so far. So if we start with boy, then we go to girl, then we go to boy. We haven't done that one before, have we? No. So that's 6. And you see where I'm going with this? I could start with, let me use a different color. I'm going to try and use that color. And let's say we're going to go girl first, then boy, then girl. That's 7. And there's one last one that I haven't chosen. And I think it is 2 girls and a boy. I think that's the right one. So if I take 2 girls to start with and a boy. So out of that, all of those combinations, there are 8 possibilities. And do you notice what's possible? Only one of those out of 8 gives me the 3 boys. Okay. Hope that makes sense. Let's see if we can use that idea in our next scenario. Now, the next scenario tells us that they will have 2 girls and a boy in any order. Okay. So 2 girls, and we want to work out the possibility. So, Abraham, let's try it. We're going to say 2 boys and a girl. We're going to say we have boy, boy, girl. We could then also have boy, girl, boy. Am I right?
Yes.
We wanting
actually
2 girls.
it's 2 girls.
But I'm just saying that those are possibilities. We could also have girl, boy, boy. None of those 3 options are what we want.
Yes.
Okay. So we could also have 3 girls. We could also have 3 boys. None of those are the options that we want. Do you agree? And I'm going to number these for the moment. 1, 2, 3, 4, 5. Okay? So arranging those, the next possibility, I could start with a girl. I could then have another girl, and I could have a boy. That's one of my desired options. Okay. What's the other desired option? I could have girl, boy, girl, and I could have boy, girl, girl. Now, I don't think that there are any other possible arrangements of arranging the letters. So what do we say? Just by doing it longhand here, what we can say is that there are 3, this is number 6, 7, and 8. So there are 3 favorable out of 8. Okay. There are 3 favorable options out of 8. Now, you need to play with that and just have a look and make sure that you understand it. Very important, what we're saying is we want, let's do it this way, in the sense that we can say we're wanting any one of this combination or that combination or that combination. What's the chances of getting this combination? It's 1 out of 8. Or we would have 1 out of 8. Or we would have 1 out of 8. So if we take all, and I just want to make this point, remember we said and we multiply. If we say or, we must add. So we're going to say 1 out of 8 plus 1 out of 8 plus 1 out of 8. Okay? And that gives us 3 out of 8. So when we work it out, we can see that we've got it right. Abram, take it away.
Thanks, John. There's some questions from the MyCities. We'll tackle them after the break. You have the challenge question, and after the break, there's more giveaways. So, guys, we'll see you after this break. Welcome back, MyCities. Exciting news we're having this awesome giveaway of airtime and cell phones. It is proudly sponsored by Vodacom. There's 3 Sony Xperia L cell phones. They are cool, guys. You should get them. There were 4, but 1 is taken. So you could get your hands on the 3 or on one of the 3. I don't know the probability or chances of you getting all 3 of them.
No, there's no probability of that. You can get 1 out of 3.
We don't know. Okay, well.
Yeah, if you win once, you're out of the draw for the rest.
Right, but also we do have 60, 55 Rand airtime vouchers. Already we've given 10, so there's 40 in store. Chances are?
Very good that you can get them, and you can win airtime more than once. You've just got to register, participate, share the page. Guys, don't share the graphic without registering, because we had it last week. There were some guys that did shared the page, 5 shares. Couldn't put you in because you didn't register. Make sure you register. Answer the question on the Curio link, follow the steps. Okay.
Of course, and the more you share, the better your chances. But you must first register on Q, and your code is LEARN, LEARN. So guys, you must write LEARN. There are 6 teachers that you need to vote for, and then go share. Like on Facebook, share their pictures, and get your friends to vote for your favorite teacher.
It's going to be tight this week, I think. There's some great teachers in that group of 6. I don't know who I'd vote for.
It's tough, John. I
It's
must
very
say.
tough, eh?
If you were there, I was gonna vote for you. Unfortunately,
No, I'm
you
not
are
there.
not there.
No, don't go there. Okay, guys, let's get on to the challenge question. Your turn to have a look at what Peter's doing. Think about him sitting in the sun there. Maybe, it could. We'll hear when he gets back, I'm sure. I was going to say about all the food, but maybe he's gone on a diet.
We need to challenge him to send us a picture.
Maybe we can see a picture of Peter at Disneyland. Okay, so what we're told, he's got the choice of different rides, and the waiting time is 75 minutes. The park is open for 12 hours. So the first calculation we're going to do is we're going to say to ourselves, let's get the hours to minutes, and let's see how we can do, how many possible waiting turns he can have. So 12 hours times 60. Make sure you don't just throw it away by trying to work out hours and minutes in different units. I've chosen to change the hours to minutes. I'm now going to say I spend an average of 75. So if I spend an average of 75 waiting in the queue, that only gives me the maximum chance of 9,6. Now the 0.6 of 70 of that gives me, really, it goes 75 goes 9,6 times in. So if I had to work out the 75 times 9, I'll show you what I'm meaning now. 75 times 9, let's do it. 75 times 9. This gives me 675. 675 out of the total amount of time, which was 12 hours times 60, which I think was 720. So that's the total time. 9 rides would give me, standing in line would give me 675. But guys, there's not much time left over. If you look 675 minutes, you've still got to go to the bathroom perhaps, minus, and you've got to get to eat, particularly if you're Peter. You're not going to go the whole day without eating. So that only gives you 45 minutes, and each ride is going to take some time as well. So if you've got 9 rides and they each take 5 minutes, you've got no time to do everything. So the chances are of you getting through more than 9 rides is unlikely. And it would be really silly, Abram, if you've done 9 rides and you go and stand in the queue.
Again.
You would stand in a queue for 45 minutes and you would not get to the ride in time because the park would close. Not a good idea. So I reckon that the chances are of you being able, that's the maximum number, the maximum number of rides you could do. How many different rides could he possibly do? I reckon at the maximum, and that's not taking any time to walk between the rides, although it did say 75 was the average. So some of them might be longer and some of them might be shorter, but we've got to take it as the average, work with the average. Doesn't give us much time to walk between rides, but I think the maximum possible is probably only 8, but let's leave it at 9. Okay. Now, the next thing, here's the probability part of it. Here's the probability part. What is the probability of Peter, now you know who Peter is, and you know what he's like, of doing no rides, okay, in the day? What do you think?
It's impossible.
It's impossible. I mean, Peter will just want to get on that ride as soon as it opens. He's not going to stand back for everybody. He's going to push people out of the way, I think, particularly if it's a funky ride. The chances of him thinking about calculating how much the airfare cost, how much the hotel come, how much he had to pay for the taxi. He did all of that. Is he going to take his family there and do no rides? No. It's almost impossible. I would suggest to you that even if Peter fell down and stubbed his toe and he got a bump on the chin, he would still get up. He's got a splitting headache. He would be on those rides. So I tend to agree that probably this is likely to be close to zero, if not zero. Close to zero. Okay. So what's the chance of him doing 15 rides in a day? Is there any chance?
No.
No. You see, we worked out the maximum rides. So this is also zero. Not chance. There's no chance. He'd have to beat all the averages. He'd have to pick all the short queues. So maybe if he did that, he might get in 15 rides. Chances are not. What's of him getting 6 rides? Well, 6 rides. Let's do the calculation in terms of time, and you'll say to me, 6 times 75. 6 times 75 gives you how many minutes? 450 minutes, and he has a total of 720. That's how much he's got. 720. So look at this. He's got that. I'm going to make this a negative, multiplied by -1 to make that a negative. Then I'm going to add 720. And I want you to see he's got 270 minutes left over. Now, if we divided that by 60, just to get an idea how much that is, that gives us roughly 4.5 hours. Now, the 4.5 hours could be having lunch, having supper, because remember it's 9 a.m. to 9 p.m. So you'd have to have lunch and supper. So that's 2 hours out of this. Let's take away 2 hours for lunch and supper and hope the queues aren't too long. He's probably got to go to the bathroom at least once. So take out half an hour to stand in the queue. That means he's got 2 hours left. I think that the chances are, with time walking between the rides, the chances are above 50%. Okay? Maybe, this was only 6 rides, maybe he could fit in comfortably a 7th ride. But I would say it's definitely above 50%. It's probably closer to 80%. Now, we don't know. We really don't know, because there are all sorts of factors that go into it. But we're just making a prediction. Okay. Abram, any questions that we've got so far?
There was just one from Mac asking that, can we still do the same questions that we were doing using the tree diagram?
Okay, so tree diagrams, guys, is something we're going to do next week. And here's something that I want you to do. If you would like to be here in studio with me, and we're going to solve some funky problems and do some hands-on stuff, you need to be living in Gauteng, and you need to have your own transport to get to Randburg and get home again. Okay, we can't bring you here, we can't take you home again. So you need to be accompanied by an adult that's got a driver's license, whatever. If you send your contact details to Abram, inbox him now. Okay, you can also send let's just leave it like that. Do it on the inbox. If you do that, we'll take the first 6 people that respond. Okay, and we'll make a team and we'll do some funky probability stuff, including some tree diagrams. Okay, so let's see if you can respond to Abram now. Get your numbers in, inbox him, and we'll get going with
The
that.
numbers in.
Their numbers in. Okay, cool. Okay, let's go on. Now, I might skip a question, so let's just see how we can do with this one. This question, one of Peter's questions, says to us, consider the diagram below, which represents a card that is divided into 3 colors. So I hope you can see those three colors. I'm just going to shade that one as blue. That's the white one. And if I'm not mistaken, that's also white. Okay, now notice how many there are. How many blocks there are. 1, 2, 3, 4, 5. 1, 2, 3, 4. So 4 by 5 is 20. Out of 20, we've got 2 that are white. How many are gray? Well, let's just tick them. We've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 out of 20 that are gray. And that must mean that we've got 10 that are blank. Let's check it though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I was right. 10 out of 20 that are blank or are gray. So the next thing is what color? So the story is this: somebody's throwing darts and they're not looking, and what's the chart? What color is the dart most likely to land on? And I think you can see from the probability graph that I did there, or the ratio, that it's most likely that it's going to fall 10 out of 20 squares are not colored. So the chances of it falling on a 10 out of 20 is going to be higher. It's in fact 10 out of 20. That's if it hits the board even. Hopefully it does. Okay, what is the probability of the dart landing on the gray color? Now the gray one was 8 out of 20. We've done it. And that's the end of that story. Okay, guys, there's one last thing in the notes that I want you to look at. Probability and maps. Go and have a look at it if you haven't looked at it already. It's a really interesting question. Interpret it and make sure that you get an answer. Okay,
Thank
Abram,
you so much,
over to
Sean.
you.
It's been an awesome show, and up until we meet again.
Yeah, we're looking forward to it. Next
Awesome.
Thursday.
Well,
guys,
guys-
make a date. Send your contact details to Abram.
Well, guys, join us and make sure that we're going to have fun next week. So do text us. Remember, as Ashraf used to say, that aim for the moon, and even if you miss it, you'll fall among the shining stars. So guys, keep learning more and learning extra with us. We love you, and it's been great. It's been great being with you guys. Remember, all the notes are on land.mindset.co.za. Up until next time, peace.